record. Okay, so here we are, 15.4, rectangles, rhombuses, and squares. Okay, so here's our plan. What we're going to do first is we're going to go through and look at all of these 7 figures and figure out what each one is. Who thinks they know what the first one is? What do you think? Was that? Yeah, it's a square, right? Because look, it's got, you know, and it's hard because not all the angles and sides are all shown up, but this is indeed, here, let's do this in a different color so it's easier to see. So this is indeed a square, this one here, okay? Let's see, so I'm just gonna try to move this, there we go. This one here, what does that look like? Is there any like distinguishing features on this besides that it looks kind of weird? There's one important set of features on here that makes this specific. What's that? It's got parallel lines, right? This line here and this line here are parallel, and these other 2 sides aren't parallel, so it makes it a trapezoid. Trapezoid. Oop, not a trapezoid, but a trapezoid. There we go. Okay, now this one here, I'm gonna help you figure out what this one is specifically. Compare this one to this one here. Okay, so let's skip this one for a second and let's do this one. What does this one look like? What do you notice about the opposite sides? What are they probably going to be? They're going to be parallel as well. So that's parallel to that. And this one is parallel to that. So if you've got something that's got 2 sets of sides that are parallel, makes it a parallelogram. Okay. Parallelogram. Okay. And I know that like we haven't covered what some of these are, so that's why we're kind of going through it together. And we're going to figure these out. And I wrote drew the diagonals in here because that's going to help us fill out this part right here. Okay, so that's a parallelogram. Now this one here also has parallel opposite sides. So this is also a parallelogram, but this one's a special type of parallelogram because all of these side lengths are also the same. So it's a special parallelogram. Anyone know what this special parallelogram is called? Rhombus. A rhombus. Good. Rhombus. A rhombus. I always think of a rhombus as like a squished square. That's not easy to say for me, but it's basically like a square that started off as a square and it just kind of like tilted over and kind of like fell over. It's like someone stepped on it, kind of crunched it a little bit. So that's a rhombus. No. Let's leave this one for later too. What about this one here? Yes, it's got opposite sides are parallel, right? So those are parallel to those. So it's really a parallelogram, but it's also a special parallelogram because these are right angles. So this does indeed make this a rectangle. Okay. And let's go back here to square. These are right angles, right? All these things are right angles. All this, let's see, these opposite sides are parallel. And then what do we know about all the sides of a square? All congruent. So all these sides are congruent as well. Okay, let's see. And then we'll worry about the diagonal stuff here in a little bit. Okay. So let's see, we've got trapezoid, parallelogram, rectangle, rhombus, square. We've got all these 5 bottoms. We have only quadrilateral and kite left. So let's look at this one here. Anyone know what this is? Okay. That is indeed a kite. Okay. And a kite, these 2 sides are this congruent. And these 2 sides here are congruent. Okay. On a kite. Right, Richard? And that's what Richard was saying, right? This is a kite. Okay. All right, so that's a kite. So then that makes this one here. What is special about this one? It almost looks like those are parallel, but they're not supposed to be parallel. Sorry, that's not a great, I should have made that a little bit more obvious. But The special thing about this one here is no sides are parallel, no, no sides are congruent, no right angles. So that makes this simply just a quadrilateral. And quad means four, lateral is side. So this is a four-sided figure. So guess what a parallelogram is? A quadrilateral. Guess what a trapezoid is? Quadrilateral. All these things have four sides. They're all quadrilaterals. Okay. So we've kind of got to start here. Okay. So let's start filling in. All we're going to do here is just place a check mark in the if the polygon has to have the given property. Okay. So quadrilateral, does that have to have four sides?
Yeah.
Yep. How about a kite?
Yeah.
Trapezoid?
Yeah.
Parallelogram?
Yeah.
Rectangle? Rhombus? No, rhombus actually has 8 sides. Just kidding. Rhombus has 4 sides too. And a square, 4 sides. Okay. This making sense?
Yeah.
You're doing okay? Better question is there something that's not making sense? And again, if you are online and something is confusing, just ask and my little chat will pop up. Get a little chat thing a lot going on. Okay. Now, let's look at this quadrilateral here. I kind of like to go through each one of these figures here and go through like every one in this column here. So both sets of opposite sides are parallel. Is that true in a quadrilateral?
No.
How about this? Let's maybe make this easier. Let's just look through our pictures here and which ones of these have both sets of opposite sides are parallel. Hold on, slow down. Let's just do one at a time. What's the first one that you see that has one?
Parallelogram.
Parallelogram right up here. This one's got opposite, both sets of opposite sides are parallel, right? So parallelogram. What's another one? Rhombus does, right? Opposite sides are both parallel. So rhombus, check. What else in here? How about let's go through one at a time. How about rectangle? Yep, rectangle does. How about a kite?
No.
Nope. Quadrilateral?
Nope.
Rhombus we already talked about. Trapezoid?
No.
Because they got one set, but not two sets. And then square?
Yep.
Yep. So this is what we're doing. We're just going through and just checking these off. And this here actually later on is going to be a big help to you. Both sets of opposite sides are congruent. Let's start over here with parallelogram. Are these opposite sides congruent to each other? They actually are. I didn't mark it down, but I should have. But these are congruent to each other, and these are congruent to each other. So both sets of opposite sides are congruent. That is true on the parallelogram. How about the rectangle?
Yeah.
That's congruent to that. And this is congruent to that. So rectangle works as well. How about kite?
No.
Yeah, these aren't opposite sides. These are like consecutive sides are congruent. So that's a little different. So kite doesn't work. How about quadrilateral? Nope, sorry, quadrilateral. Rhombus?
Yes.
Yep. In fact, they're all the same, but that still means that both sets of opposite sides are congruent. So that works. And then trapezoid?
Nope.
Nope. How about square?
Yep.
Look at that. Okay. We're getting somewhere. Is this helpful going through this together, I hope? Okay. I really want to go through this whole thing together just to kind of, see where we're at and get it all figured out. Richard, you getting this all filled out that we're like, literally giving you all the answers for? Yeah. Okay. So Richard, pull your head up and start writing. Richard, it's not nap time. Nap time's later. You literally have like 2 days at school and 5 days not at school. You can use those 5 days as nap time. All right, you got this. Here we go. Both sets of opposite angles are congruent. So let's see, opposite angles. Okay, we haven't looked at this. How about this on the parallelogram here? Are these opposite angles and these opposite angles the same?
Yep.
They are, because that's what we just did the other day, right? So those are congruent to those, and this is congruent to that. Those opposite sides are indeed congruent. So that's parallelogram. How about rectangle? Are those opposite angles congruent? Heck yeah, because they're all right angles. Let's see, a kite. These angles, like this angle here and this angle here, those are the same, but these are not the same, are they? So we don't have both sets, so kite doesn't work. How about quadrilateral? Quadrilateral is just getting no love on this thing here, is it? That's okay. Rhombus, what do you think? Opposite sides, are those the same? Opposite angles, sorry, not sides. Yes. These opposite angles are going to be congruent, and so are those opposite angles. So rhombus works. And then how about square? They're all right angles, so yep, that works too. Interesting pattern. Now we're talking about diagonals. Diagonals bisect each other. What's bisect mean again? Cuts them in half. So parallelogram, do these look like they're getting cut in half? Yep, and they are. So gosh, you know what? I'm going to do a different color just to make this hopefully a little easier. So that length is the same as that, and that length will be the same as that. So parallelogram, check. How about rectangle? Yep. In fact, these are all the same, but they bisect each other. So parallelogram works. How about kite? This one is the same as this, but these two are not the same. So kite's that kind of special, different quadrilateral. How about quadrilateral? No love for the quadrilateral. How about rhombus? Yep, this is the same as this, and this segment is the same as that. So rhombus works. Trapezoid? Nope, that's definitely not the same, and that doesn't bisect either. And then how about square? All those things are the same. Look at that. Okay, trust me, this pattern will not continue forever. But let's see. Consecutive angles are supplementary. Wow. Okay, that's a little bit of work. So if how about this? If consecutive angles are supplementary, what do you know about the opposite sides if they're supplementary? Yeah, but now we're talking about just the sides themselves, because if you can make this connection, that's going to make, because this is going to be a little tricky to figure out, but there's a way that we can figure these out. So how about this? Parallelogram, are these two going to be, are these two consecutive angles going to be supplementary? What do you think? How do we know if those are supplementary or not? If these two sides are what? Parallel. If these sides are parallel, then these consecutive angles here have to equal 180, right? Because if you go back to think about remember when we had our little drawing here, this line here is parallel to this line. So these two angles here have to add up to 180 degrees every time. So if we have opposite sides that are parallel, guess what? Then the consecutive angles also have to be supplementary. I know that's a little bit of a reach. That's a tricky one. But look, if you look in parallelogram, these two will have to add up to 180. These two here will have to add up to 180. These two will have to add up to 180. Those two will have to add up to 180. So consecutive angles are supplementary for parallelogram. Check. Okay. So rectangle. Yep, because, and again, the key here is if the opposite sides are parallel, then that means that the consecutive angles are also going to have to be supplementary. So opposite sides. So this one here and this one here, these are connected, right? So parallelogram has opposite sides. Both sets of opposite sides are parallel and their consecutive angles are supplementary. Rectangle, guess what? Those are also consecutive angles are supplementary and both sets of sides are parallel. Rhombus, look, these are going to add up to 180. These are going to add up to 180, 180. And then same thing with the square. Those are going to add up to 180. Those are going to add up to 180, so forth and so on. And then the trapezoid, kite, and quadrilateral, these are not necessarily going to be supplementary. Those aren't going to necessarily be supplementary. And these will be, but these two won't. So the trapezoid's a little bit special, but with the two parallel sides, this angle here and this angle here, those are going to end up to be supplementary, and same with this angle and this angle down here. But these two are not supplementary and these two are not supplementary. So that makes this trapezoid a little bit, it's got half of it, but it doesn't have all consecutive angles supplementary. Okay, hanging in with me a little bit. I know that's a little tricky. We'll get there. Diagonals are perpendicular. So what's that mean? How can we figure out if their diagonals are perpendicular? What's perpendicular mean again? Come on, I know you know. It makes a what? What's that? I can't hear. I just can't hear because you guys, yeah, they do intersect, but they intersect if they're perpendicular. What are perpendicular lines? What do they look like? What kind of angles do they make with each other? There we go, 90-degree angles. So if they're perpendicular, they're going to have 90-degree angles. Does this look like they're all 90-degree angles?
No.
Nope. How about rectangle? Nope. How about kite? Yeah, that one is. All these are right angles. So a kite has diagonals that are perpendicular. Look, kite finally got back on the board here. They're catching back up. How about quadrilateral? Nope. How about rhombus? Yep, these are right angles. So rhombus works. And then how about trapezoid? Not necessarily on that. How about square? Yep, those are going to be right angles. So now, ooh, look, we finally broke our pattern there. Right? All right, and then this one is going to be a little bit quicker to go through. 4 right angles. Which ones of these have 4 right angles? Just taking a quick peek. What's that? Rectangle and square, right? 4 right angles, 4 right angles. None of the rest of these have 4 right angles on their actual, where their sides meet here. So rectangle and square, right? I've got 4 right angles. 4 congruent sides. Which of these have 4 congruent sides?
Square.
Rhombus and square. Good, right? Rhombus and square, right? These, all those sides are the same. All those sides are the same. None of the rest have that. Okay. Last one. And then this will help us. Wow, that's weird. The looks like the screen is like pulsating a little bit, doesn't it? Hope that's, if that starts giving someone a headache, you let me know and we'll get it figured out. I'll try to figure that out later. That's weird. Sorry. Exactly one pair of opposite sides are parallel. Now this is different. Exactly one pair of opposite sides are parallel. So both sets of sides of opposite sides here are parallel. Both opposite sides are parallel. Are either of these, do we have exactly one that's parallel here? Neither of those are parallel. Quadrilateral, sorry, quadrilateral, you don't have anything going for you besides your 4 sides. Does this have exactly one pair of opposite sides rhombus? Nope. Trapezoid? Yes. Exactly one pair of opposite sides are parallel. That's the trapezoid. These 2 sides are parallel and these other 2 sides are not parallel. And then how about square? They've got 2 sets. They don't have exactly one set, they've got 2. So square, sorry, square was like on a roll, had everything checked off except for the last column. Okay, so now we've got this lovely thing filled out. Okay, and then this is going to help us with the rest of this lovely worksheet here. Okay, now it's going to be a little tricky because we're going to have to refer to this while filling in the rest. And it's easy if you have it on your piece of paper. If you happen to have this, because you can see it at the same time. But if we're online here, we're going to have to we're going to hop back and forth between the 2. Okay, so with that, we're going to look at trying to do 2 and 3. All right. Fill in the correct term in each region in the Venn diagram with the correct term in the list. So they gave us this one here. So we've got 1, 2, 3, 4, 5, 6, 7, 8 things. Problem is back here on the other page, we only had 7 things. So what's the new thing that was added? Isosceles trapezoid. Sorry, I'm trying to get, I can't get to my, oh, there it is. Oh, no, that's not it. Okay, so sorry, we're looking back here. So we had everything except for isosceles trapezoid. So we put that one in there for you. So, like this is like a Venn diagram here. So what is everything? Oh, shoot, sorry, I keep hitting the wrong button here. What's everything in here? All these figures here are all what? Quadrilaterals. They all have 4 sides. So when we are looking at this here, oops, gonna turn that off. All these things in this circle here are quadrilaterals. Quadrilateral. Okay. Okay, all these things are quadrilaterals. Let's see. So isosceles trapezoid. What do you think is probably going to go up here with the isosceles trapezoid? Probably trapezoid. So if we have a trapezoid, all isosceles trapezoids are also trapezoids, right? So remember, isosceles trapezoid, the difference between an isosceles trapezoid and a regular trapezoid is, like, let's say here's a trapezoid. Right, we've got this side is parallel to that side. An isosceles trapezoid has what? Well, if it's got two sets of parallel lines, then it's a parallelogram. But I think I know what you're talking about. Right, equal sides. So these sides are still parallel, but then these side lengths, which it doesn't really, I've tried to draw them so they were the same, but these opposite sides, they're called the legs. Those are going to be congruent. So this is isosceles trapezoid, and this is just a plain old trapezoid. Okay. Now out here, well, let's see, we've got 1, 2, 3, 4. So let's go back to this here and see what these here. Look, parallelogram, rectangle, rhombus, and square all have a lot in common. Okay. What's like the, so we got square. Let's do this. I'm going to circle these, or just put a little star next to them. Square, rectangle, rhombus, and parallelogram. These all are connected here. So now we got to try to figure out how these are going to all connect. Okay. So if you think about it, all of these are what? All four of those things we could qualify as what? They're all parallelograms, because all of these have opposite sides that are parallel, and that's all we need for a parallelogram, right? So on this here, oops, keep forgetting, all of these things in this circle are what? Parallelograms, Lucy just said. So let's do this. These are all parallelograms. Sorry for the color change, no significance in that. Parallelograms. Okay, parallelograms. And then now we've got these things here. So then they're going to be, the rest of the three are going to be sharing some information here. Okay, so we took care of parallelogram, check. Now, rectangle, rhombus, and square. Let's see, squares and rectangles have all right angles, right? Rhombuses and squares have opposite sides that are, like have all the same sides are congruent. Sorry, all the sides are congruent, right? So what do you suppose? Again, this is a tricky thing to do. I would never test you on this. This is just to kind of help you understand the relationships between all these. Which one of those three that are left, rectangles, squares, and rhombuses, have the most in common? Like have something in common with both the other ones?
Square.
The square does. So if we put square in the middle, right, we got square is a parallelogram, and then the square has something in common with a rhombus, where all the sides are the same. So everything in this circle, all sides are congruent, and then also have something in common with a rectangle, where all the angles are right angles. Okay. And then what's our one thing that's left over? Kite.
Okay.
Yeah, poor kite. Kite's got some special characteristics on its own, but it just doesn't have a lot in common with all the rest of them besides the four sides, hence the quadrilateral. So here's how you can go through and read this. You can say, hey, look, I know that a rhombus is a parallelogram and it's also a quadrilateral. So anything that surrounds that thing, it is included. A square is both a rhombus and a rectangle, and it's also a parallelogram, it's also a quadrilateral, but it's not a trapezoid and it's not a kite, right? An isosceles trapezoid is a trapezoid and it's a quadrilateral, but it's not a kite or a parallelogram or anything else like that. That's kind of how we read that. Okay, so let's do this. Using that idea, I'm gonna have you guys try out number 3, and then we'll get back together and we'll try those out. So let's do this. Let's shoot for, like, we are at 9:02. We are here till 17. Let's do this. Let's shoot for doing, I'm gonna give you 5 minutes to try to go through and figure this out. And then we will come back and work on this together. Okay, so I'm just gonna leave this recording going. So if you're watching this, then that gives you 5 minutes to go through and try these out. And then we will come back together and check our answers. Okay, okay, 5 minutes starts now. Ooh, I even have like a 5-minute timer. Let's see if I can find it. Oops. There we are, countdown timer. Ooh, look at that. Okay, so we're probably about 30 seconds in. Let's see. That. You guys have questions? Oh, you're gonna figure that out and we'll work that next. What's that part? Okay. Oh, you're pretty self-confident. Yeah, right. Okay. Probably take a little bit more. Let's just do all this stuff. Give me a little over a minute left. If like some people have fair amount of people have moved on to the back side. So yeah, if you're finished with the front already, just move on to the back side. But then in another minute or so, we'll check the front, the rest of the front together. And then we can keep checking on the back.
We get in the morning. I like the wake in the morning. Yeah, you think this is, well, you should see me victory after I've eaten lunch and I'm awake. And I have friends in that class. Yeah, I didn't know that. It's good because when I have friends,
It's hard for these, except what part of the my face, but yeah, I don't quite why is it?
very lucky to be in other subject classes like that and other subjects that talk nonstop.
All right. Let me turn that off.
My
We
middle
don't
school
need
teacher
that.
hated me because I'd always talk and then I'd get good grades, so they couldn't say I wasn't paying attention, I didn't know it, and we pay attention.
Of course they couldn't. There we go. Okay. Let's go together through these here. All right, you guys, let's, ooh, sorry, you guys can't see what happened. That is really strange. Okay, let's see. Give me a second here. I have to fix my projector here. Oh, there we go. Duplicate. There we go. Okay. So with this one here, first one, you guys, what do you think? All rectangles are parallelograms, true or false? Okay, so if all rectangles are parallelograms, and that means the rectangle will have to be inside the parallelogram circle, and that is true, right? Some rectangles are trapezoids. Are any of the rectangles, any piece of this circle in the trapezoid circle? No, so that would have to be false, okay? So I know that this, like coming up with this Venn diagram thing, that was difficult. But with this Venn diagram, I want to show you the purpose of this Venn diagram. This can help us answer every one of these questions down here. So let's see, third one, all parallelograms are rectangles. So is everything in here a rectangle? No, because look, rectangle only covers this. So like there's can be some like rhombuses are parallelograms that are not rectangles. So all parallelograms are rectangles. That would be false. And again, a reason for that is a rhombus is a parallelogram that's not a rectangle. And then you've got all sorts of just regular parallelograms that are not rectangles either. Okay. All rectangles are quadrilaterals. Is this inside all of the quadrilateral circle? Yep, because the quadrilaterals is the whole thing. So this is true. Good. All squares are rectangles. Are all squares rectangles? What do you guys think? Because a square has to have, let's see, what they're really asking is like all squares have to be rectangles. Rectangles just have to have opposite side, like all angles are right angles, right? So are all angles in a square right angles? So that would be true, right? Okay. All rhombuses are squares. Are all rhombuses squares? All you have to do is come up with one instance where a rhombus is not a square, and then that would be false. And right, the example that we have back here, this is a rhombus that's not a square because all those opposite sides, all the angles are not right angles, right? So well, that would be false, right? All squares are parallelograms. Are the squares inside the parallelogram circle? Yep, so that would be true. Some squares are kites. So is any part of this square circle intersecting with the kite circle? Nope, so that would be false. Okay, and then no rhombuses are trapezoids. Are any of these rhombuses in the trapezoid circle? Nope, so this is the weird because it's the double, it's like the negative thing. No rhombuses or trapezoids, that's actually true. Right. Because none of the rhombuses are trapezoids. That's a true statement. Okay. Okay, so then here's what you want to do. Continue on the back. We will also, let's see, you can work on this some for asynchronous time, but I also want you to look at the 16:1 note. So we will take some time in next class to also finish off this, and then we'll look at the 16:1 worksheet as well. So with the rest of the time you have in here and with some of your asynchronous time, work on 4 and then 5. I think that's all there was on the back, right? Just 4 and 5. Okay. Good, good. Okay. I'm going to